Hi, everyone, for those who just joined. My name is Marcin, and today I'm going to talk about building GraphQL in Python and Django. So my talk is called Real World Graphene, Lessons Learned from Building GraphQL API on top of Django app. Yeah, so to quickly introduce myself, my name is Marcin, as I said. Yeah, I come from Wrocław in Poland. Um, I work as a Python developer here at a company called Mirumi Software. We are a software house um, specializing in e-commerce, but we also do other web apps with GraphQL and React. We use Python as a backend mostly. And for the last 2 years, I had the pleasure to be a lead developer at a project called Saleor, which is like one of our most important projects right now. Um, yeah, so what's also important here in Wrocław, we are doing GraphQL Wrocław as well. I didn't mention that before, but this is also something that you might be interested in. Anyone listening to this event. So yeah, we have our own meetup here as well. We have quite many members there. Like on every meetup, we have like 100 and 150 people. So it's really big community of developers here in Wrocław in Poland. So uh, if there is anybody else like interested in joining us and speaking at our event, it would be great. Just contact me. Yeah, so I want to introduce you to Saleor because this is pretty important in the context of my presentation because like this project is where we start the journey of GraphQL. So Saleor is basically an e-commerce platform. It's open source, so you can find it on GitHub. And well, I'm it's it depends how much familiar you are with e-commerce, but I'm sure that many people heard about Shopify or Magento, WooCommerce, stuff like this. So Saleor is something similar. You can think about Saleor as Shopify but open source, or for example Magento, but built with a little bit different technology because like we use Python, which is at the very core of our platform. Uh, we believe that this makes our product um, like better in terms of code quality, for example, because this is open source product, so it's really important to have good code quality there. So this entire platform consists of few parts. So this is a screenshot of the dashboard application. So this is where you manage your shop. Basically, this is a front-end app built in React. It's using GraphQL underneath. Um, Here we have the storefront application. So this is a kind of template of a shop that you can take from GitHub as well and build your shop using this template. And few facts about our API, because all of that is powered by GraphQL API. So we have now about 50 queries, 200 mutations, and 500 types. So this is like few statistics to give you an overview about size of the API currently. We have JSON Web Tokens based authentication and permissions system. From like the more cool features, we have service accounts and webhooks. So this means that you can not only use that API for your front-end apps, but you can also build integrations like other services that can authenticate in our API and fetch some data or get some notification by webhooks. So this is really cool. And what we really like about our API is also that we have pretty unified way of filtering, sorting, and search in all top level queries. So these are a few facts. Actually, I have like the running app on my machine, so I think it can be interesting to see how it looks like. So this is the dashboard application. Um, this is where you manage your shop. uh, Here's, for example, the list of your products. You can go to product details and do some kind of management here. We have orders management, customers management, and all kinds of features that you might need in e-commerce. What might be interesting for you is that, as I said, it's all running on GraphQL. So if I reload this, then you can see that there are some GraphQL requests underneath. Like for example here, yes, that's data from our e-commerce API. Um, so in this case, we are getting, for example, customers data. Um, yeah, so this is pretty exciting. This is like huge React app that works really well here with GraphQL. Uh, Here is our storefront application. So as I said before, this is just a template of the shop that you can customize. And it's also a single page app. It's using GraphQL underneath. And here we have also the playground. So if you don't need any front end, you can just use this API, for example, to get data of your products. So for example, here is a query to get products from my shop. So for example, I have apple juice, and here I have a bunch of variants of that product. So yeah, so this API gives you access to all kinds of e-commerce operations that you might need. Uh, so you can use it standalone, or you can integrate that with your existing solutions. So if you are interested, um, we have, so this is all open source, as I said. Um, so go to github.com/mirumi/Saleor if you are interested in using this. We also have public demos, so if you want to just try out without installing it locally, then use that demo to play with the platform. So I'm talking about this entire application because that's where our journey with GraphQL has started. So this entire app was initially built as a Django, like purely Django project. So for those who are not familiar with Django, this is like classic framework where like you have model view controller pattern. So it's all a huge monolith where like both front end and back end lives in the same code base. So that was fine for us for a few years at the beginning, but at some point you start to realize that if you want to introduce some extensions like integrations with other services, then you might need API. And we had no API before adding GraphQL. And also you will notice that maybe those static templates that you have in Django are not enough to build a first-class user interface with dynamic features. And like modern apps have really complex UI, and this is not achievable with static HTML templates. So after having this Django-based architecture for many years, we decided to add GraphQL layer on top. So this is what we've actually ended up with. So on top of our Django ORM logic and all the Python logic that does the business stuff, we've added GraphQL layers, so it's built with Graphene. And we've moved all of our, like two of our front-end apps um, outside of the project, of the core, and now they are separate apps built in React and Apollo, and they use GraphQL as you've seen in this short demo before. So this is like the new headless architecture, which also allows us to build external integrations around the platform. So this is a really great benefit of having API, and especially GraphQL API here. So yeah, as I said, we are using Django for the backend, and when we started doing this transition, it was like 2 years ago or something like that. The only framework that was available was Graphene, and it's still the most popular framework for doing GraphQL in Python. So we are using that currently. Um, yeah, it's a code first framework. So um, we are building GraphQL with Python classes, Python functions, and the schema is generated uh, from that. And yeah, Graphene has support for popular Python web frameworks such as Django or Flask, but you can also use it standalone, let's say, if that's your use case. So in this matter, this is a pretty flexible framework. So yeah, basically now I'd like to share a few lessons that we've learned over those 2 years of using Graphene at Saleor that you won't necessarily learn from the docs, or you wouldn't necessarily know after a few months of playing with the framework. Yeah, so let's start with like maybe one of the biggest benefits of Graphene, in my opinion. So the first lesson is that Django plus Graphene lets you rapidly build APIs. So it means that this duo of Django and Graphene is really powerful if you want to prototype something very quickly, or if you have large existing code base and you need to add GraphQL on top of that. So Let's see why it's like that in Graphene. So yeah, let's look at how we define data in Django. So this is a simple class that represents a user. Um, yeah, so I think that it's pretty similar in many other frameworks as well. We have a bunch of fields here. We are using Django or ORM here to use some fields like emails, booleans, or datetime. Uh, so this class would be later transformed to a database table, right? So this is how most frameworks work, I suppose, that support ORM solution. So we had a lot of models like this in our code base. And now, if you want to represent that in GraphQL, what would you do in Graphene? In this framework, we are building simple classes like this one. So again, this is called user, this class. And this is very simple because here in this meta class, we are saying that we want to map fields from the user model. And by using this Django object type here, this class would magically uh, like use those fields from our model in our type. Here we can specify which fields exactly we want to map. So this reduces the risk of accidentally um, leaking some private fields, for example. So you need to make sure that you have only the field that you want here. And basically that's it. That would out of the box also generate all the field resolvers for us. So this is pretty convenient. Uh, to bind this type to the schema, we need a query. So this is how we define queries in Graphene. Again, we are using object types, and here we define this is the listers. It's using the user type, and we also have the resolve users function, which just takes all data from the database and returns that in this query. So these few lines of Python code would result in this schema. So that's how the code first approach works in Graphene. It's, as I said, it's pretty convenient if you have existing code base, and you are adding GraphQL on top of that. So that was exactly that's what was our case for using that. So to summarize that, mapping models to types in Graphene is effective if you are building on top of existing code base. Um, you have full control over the field resolvers, like they are mapped automatically, but you still can control like how they behave. If you want to add some permissions, for example, to a particular resolver, you can do that easily. And what's also important here is that Graphene uses syntax, like style of programming that is declarative, which is very similar to what you do in Django. So if your team is starting with GraphQL and uses Graphene, then it's really easy to dive in because you have the same programming style, the same patterns used in both frameworks. So this is really convenient to use. So that's the first lesson about building types. Um, so now let's talk about mutations. So it seems that after building all of these mutations in our API, it turns out that mutations are a bit more tricky in Graphene, and this is not so obvious how to do that right when you start doing this. Um, so let's see how you build mutations by default in Graphene. Um, yeah, because I'm talking about Saleor, which is e-commerce platform. I have examples here like this one. So for example, creating a product. Uh, so what is going on here? We have a class called create product. What is important in Graphene, every mutation is a class in this framework. So here we specify the input data in the class arguments. Here we specify the output of the mutation, so fields that would be returned as a result. In this case, we want to result a new product. And here is the actual body of the mutation, so the resolver. So here we say what should happen when this mutation is called. And in this case, we are just getting data from our input. We are passing that to the model instance and saving that in the database. So this is like very simple example of how a mutation would look like. But in real life, if you have a lot of operations like this and many business rules, this is usually more complex. So first of all, there is no common pattern for input data validation. So for, like, pretty often you want to have some business rules on the input that you are passing to the mutation. There are some constraints that you need to check before saving data. So there is no like easy way to do that in Graphene, or maybe let's say like it's not obvious how to do that well when you are starting. Second problem is that there is also no established pattern to return errors in Graphene. So if we have some validation errors during the mutation execution, there is like you as a developer have to figure out how to return those errors efficiently, and you have to establish your own patterns. It's not given by Graphene. Like so this is kind of problematic at the beginning. And if you have a lot of mutations like this, and you add all of this business logic here, this would result in pretty large classes. So you would end up with a lot of boilerplate code. So we had to fix this somehow. And what we did is we introduced few abstractions. So these abstractions are not provided by Graphene by default. Um, I mean, there are some abstractions that, for example, allows you to migrate from Django REST framework, which was like most popular framework for building REST APIs, but not if you are starting with pure Django app. So here I want to show a few patterns that we've developed over the last 2 years. So let's start with unified errors handling in mutations. So we have this little abstraction called base mutation, and yeah, so here are a few things going on. First of all, like we've added our own resolver for that mutation, which is called perform mutation. And as you can see here, we are calling this resolver inside the default resolver provided by Graphene. So and this perform mutation function is wrapped with try except block, which basically looks for any validation error that could happen during execution of that mutation, and it does some job to format it nicely. So we don't have to care at this point what it does, but like this is like one of the responsibilities of this base mutation class. And here, as you can see, we have the errors field. So now every mutation that extends this base mutation pattern, would get this error field as one of the output fields. So if we use that constantly across our code base, we have unified error handling, because now every mutation has like very similar shape, um, which is what we want to have. Um, yeah. So for example, if we take again this product create mutations as an example, so you can see what we have here. We have some input data, and below we have the errors field. And for every error, we are returning field, message, and code. So field tells us which input field uh, resulted in an error. Message is actually meant for the developer. It's not to be displayed in the front end. And that's what we used to do, but actually it doesn't work in the long run, because usually you have your translations in the front-end code and not in the back-end code. So you cannot show those messages in the front-end simply. So for that, we have those error codes. So front-end is supposed to interpret those codes. And because these are enums, so for example, here is the response, the error response. So for example, we have codes like unique and some field name. There is constraint that it must be unique. And now if you have a bunch of codes like this, and they are enums, so they are defined in the schema, front-end developer can handle that easily and display proper message in the front end. So having those base mutations allows us to do that in every mutation that we have in Saleor. So this is pretty cool, and that's something that wasn't available in Graphene by default. Yeah, in our case, you've seen we have this dashboard application, which is basically large CRUD app, uh, because there is like a lot of views where you have just create new products, create new categories and stuff like this. It's just a lot of mutations that create and edit stuff. So and if you are building these mutations, you will quickly find out that they all follow the same pattern. So first, you want to clean the input data because you have some validation rules. If this data is fine, then you want to create the a model instance from that data. Then you want to validate it again, maybe, and lastly, you save that to the database. So we had a lot of mutations that followed exactly these 4 steps. So what can we do to make it easier to add these mutations? So we've developed another abstraction called model mutation. Um, I'm not gonna show the source code of that because that would be maybe too difficult to understand on such short talk, but uh, this is just to give you idea how it looks and how it works. So we only say that this mutation uses the product model, and inside it knows how to, yeah, and it also takes the input object as an argument. And inside it knows how to clean the object because we have the validation rules defined at the model level in Django. And it does all the magic to generate this simple product create mutation. And it's very powerful because if you want to override particular step of for example, this flow that that we've seen on the slide before, there are just a bunch of methods that you can override and customize this flow. So we have types, we have mutations. So what about subscriptions, which are one of the most powerful features of GraphQL? So it seems that if you are using Django, there is no native support for subscriptions, unfortunately. Um, so the thing is that Django, as I said, is kind of classical MVC framework, and it was also designed for this request response pattern. So it doesn't handle very well asynchronous connections, such as, for example, um, sorry, I lost the word, not webhooks. Yeah, anyway, asynchronous connections. So this is a synchronous framework, basically. And for example, database access is synchronous, and there is no way to change that currently. So that's a huge blocker. So we cannot have subscriptions because of that by default. But there is a solution called Django channels, which wraps entire Django application with additional layer that is able to process async requests. And this is still pretty new thing. It's not so common to use, so not many people use that actually. And yeah, so technically it would be possible to have subscriptions with Django. We haven't tried that because we yet haven't like use case for subscriptions in our application, but that's how it looks like currently in Django and Graphene. Um, yeah, so this is database sync to async is kind of one of the tools you have to use with Django channels to have access to the database. Um, so this is kind of possible, but it's also a third-party library. It's something unusual, so yeah, it's kind of problematic in Django to support subscriptions currently. So this brings us to the fourth lesson that we've learned, that if you are building fully-fledged API in Graphene and Django, you need a bunch of additional libraries. Um, so for example, uh, I said before that we support JSON web tokens for authentication, and that's true, but it's not provided by Graphene by default. You need additional library for that. Um, Also, to have permissions management based on JSON web tokens, you also need, like, it's the same library basically, which is fine because you can have this feature, but there is always a risk with using third-party libraries because you will never know if they will be maintained, because very often they are maintained by one person and or very small team. And yeah, it was problem for us a few times already that we have to be dependent on some kind of library that it's not supported. The same is for Apollo Federation. It's also not built into Graphene by default, but there is one library that can give you this feature. Um, Also, file upload. I know that file upload is kind of there is no agreement on how to do that well in GraphQL. There are a few patterns. Uh, for us, we wanted to have the basic file upload through a mutation, and it is possible to do that through multi-part requests in GraphQL. But again, to support that, you need another small third-party library in your stack to have this feature. Some features are actually not implemented at all. So, for example, query cost analysis, which is a feature available in Apollo server, for example, but in Graphene, it's not available yet. And there are some open issues about that, and actually I'm not sure what's the state of those issues, and that would be pretty useful in our case because you can use our API in the like headless solution. So we need to support query cost analysis at some point, and probably we will have to build support for that ourselves. So these are like the 4 lessons that I've prepared. There would be much more stuff, but I think these are the most important ones. So we've seen that there are some benefits of Graphene, but there are also some downsides. So you may be wondering, why do you guys use Python? Because there are some really well solutions on the market, such as Apollo server, which is probably one of the best GraphQL servers out there. Um, so why don't you just migrate to Apollo server since you've had to migrate your entire architecture? Yeah, that's a really good question, and we've been asking this question ourselves. And the answer is pretty simple for us. So the answer is that we are huge fans of Python, and basically we decided to invest more time in this language and GraphQL support in this language. And that's why we started using Graphene, and now we are actually developing our own framework. Um, yeah, and what I want to show here is also how the modern Python looks like. So for example, this is Python 3.8. So the newest version now. So you have async await support in Python. So you can do all of the asynchronous stuff right now. So it wasn't available when Django was created, for example, but now it's totally doable. So we believe that Python is growing, and actually there are proofs that Python is growing because that's how it looks like compared to other languages. Because of data science, machine learning stuff, where Python is very popular, and also web development, Python is growing really strong nowadays. So this makes us believe that it's really worth investing time in developing solutions for GraphQL in Python. So last thing that I want to show you is Ariadne. So this is our own server for GraphQL that was inspired by Apollo server. Is a schema first framework, and it has all the async features plus subscriptions. Um, it's still quite early for that framework, like early days, because for example there is only very basic integrations with Django. So probably adding support for that is on our roadmap, but you can use that already to build, for example, federations, and we use that as well. And yeah, it's really cool framework, and we want to invest a lot of time in this. So we believe that it's really worth to do in the Python community. So that's all I have. Thanks for listening.